Hello students, in lecture 3 of design of reinforced concrete structures, that is design of continuous beams, we have discussed some of the guidelines of Indian Standard Code IS 456 regarding the design methodology which need to be adopted while designing continuous beam. So design as well as analysis, code is giving some recommendations or some limitations. So in lecture 3 we have discussed how to work out or how to calculate the effective span in case of a continuous beam. So today's topic, let us let us go to step number 4, very important step in the design of the continuous beam or any beam or any structure member. Very important aspect is when we have to do the design calculation, before that we have to work out what should be the load calculations. That means what are the various loads which are expected to come or the beam will be subjected to its life period. From the assumed dimensions of the beam section, which we have discussed in the previous 3 steps, dead load and live loads are calculated as UDL, as a uniformly distributed load. Then according to table number 18 from IS 456, we will be working out partial safety factor in case of limit state methodology of the design. So partial safety factor values will be taken from table number 18. Then factored design load will be worked out. Now factored, first one, we have to calculate factored dead, or you can say self weight, in which we will be including floor finishes load, which you can assume based on the experience, etc. if required. So that means if you need to take into consideration floor finishes, so that load you have to be assumed and need to be included in the dead load, which you can term as WD in kilonewton per meter. Be aware that in this factored dead load, first of all you will be calculating dead load of the beam member, then you will be applying it, multiplying it with a partial safety factor. Generally we take 1.5. For detail you have to refer this table number 18. So table number 18 you can refer IS 456. Then next is factored live load or imposed load. Now again code is suggesting us whether factored live load is a fixed load or is it a movable load. So you will be naming it as WL kilonewton per meter. Then we will switch over to step number 5. As we have already discussed, a continuous beam which is more than one span is an indeterminate structure. So either you have to follow or use any indeterminate method, that is method to calculate the bending moment and shear force for indeterminate structure, just like Kani method, moment distribution method, or any other specific method which is relevant. But here, because code is recommending an approximate method to calculate bending moment and shear force calculations, so some of the bending moment as well as shear force coefficients are given in the Indian Standard Code. So they are known as moment coefficients and shear coefficients. So moment coefficients and shear coefficient can be taken from clause number 22.5.1 IS 456 for the calculation of factored bending moment and shear force values. But here we have to note down what code is restricting or code is suggesting us to take the moment coefficients for the calculation. But here code is saying that all these moments coefficients as well as shear coefficients, before taking into consideration we have to check whether these conditions are fulfilled. So few conditions are suggested by code before just picking the moment coefficients and shear coefficients for the calculation of bending moment and shear force. So very first point is the continuous span should be at least 3 in number. So you can use these coefficients for calculation of bending moment if the problem which we are going to deal with or you are designing, then continuous beam should be having span numbers more than 2. That means it should be at least 3 span continuous beam. Then you can easily use these coefficients for the calculation of bending moment, and you can easily use this approximation method which is giving the values which are very near to the values calculated with the help of indeterminate methods, that is Kearney method or moment distribution method. Second point is support should be fairly rigid and should not themselves deflect. So very important part is all the supports on which continuous beam is supported, they should be rigid. That means there should not be any movement or deflection of the supports. Third point is all the spans should have the same cross sections. So that means if you need to vary the cross section of different spans, then you have to do the calculation of bending moment and shear force maybe by moment distribution method, which you have studied in structure analysis part 2. Otherwise, in general, we will be using the same section throughout the different spans in case of design of continuous beam. But if there is any special requirement or special condition, then you have to go through the moment distribution method for the calculation of bending moment. Fourth point is the effective length of each span should be more or less same. So because it is an approximate method, so it is better to keep all the spans of equal length, and at any rate should not, if they are differing in the length, that means if one span length is differing from the another span, then code is saying that they should not differ more than 15% of largest span. So these things we have to take into consideration. Fifth point, the loading on all the spans should be substantially uniformly distributed load. We have already discussed that we will convert the load into UDL. No redistribution of moments is permitted in this approximate method which is given by Indian Standard Code. So for what is redistribution of moment, you go through various resources available, but for the time being in this DCS2 we will be only designing based on approximate method given by Indian Standard Code 456. Now step number 5 is continuing. You can refer table number 12 for bending moment coefficients. That means table number 12 in IS 456 is given from where you have to take these coefficients. Now if you see here, let us go through this table number 12 minutely. You will find here type of load is given in first column. So that means if you consider dead load and imposed load, both are fixed loads. That means no load is movable. So generally this happens whenever you are going to construct a building. Maybe it is multi-story building, single-story building. But second case is imposed load not fixed. These type of loads you will encounter in case of bridges where vehicles are moving. So in case of bridges, we generally consider the live load is due to vehicles. So because vehicles are moving on the bridges, so if you are going to design a beam which is a part of a bridge, then you have to take into consideration these guidelines, imposed load. Now in second column, what you see, there are span movements are given. Now there are different spans. If there is a continuous beam, suppose a continuous beam is of 3 span or 4 span. So you will see that first of all there will be end span. We will divide the continuous beam into end span, which are the farthest end supports which are linked to end supports, and then other spans are known as interior spans or intermediate spans. So if there is a 4 span continuous beam, then there will be 2 end spans and 2 intermediate spans. So but code is saying for the span movement, when you have to take the movement coefficients from this table, so this column gives you the value for bending moment coefficient near middle of end span. Now we are talking about end span. When you are going to design or you are going to calculate bending moment in the end span, then you have to refer this column. Here what is mentioned, near middle of end span, and we are very much aware that when you calculate bending moment at supports in case of a continuous beam, so those bending moments will be negative, but when you are getting the value throughout the span, and it will be maximum at the middle span, mid of the span. So when you are talking about the end span, so then you have to take, if case of a building, then dead load and imposed load both are fixed. Then when you are going to calculate maximum bending moment near the middle of end span, then you have to take coefficient 1/12. And interior span or intermediate span, which we have discussed, when you have to calculate bending moment at the mid of the interior span or intermediate span, then you have to use this coefficient. Okay, so when support moment we are calculating, as already we have discussed that support moment are negative bending moment, so you will find here negative coefficients at support next to end support. Now this table is not giving any movement coefficient value for end support. So here next to end support, that means you can say support number 2 from any end. So next to end support you will take this value when you have to calculate bending moment at the support level. And then if you go through this column, then what do you find? Other interior supports. So this may be support number 3, which is supporting the intermediate span or interior span. Then you have to take this value of coefficient minus 1/12, and correspondingly in case of movable load you can take these values. Now if you see here, which we have highlighted, so continuous beam and slab having fixed loading, that is beam or slab in case of building, as already discussed, and similarly you have to use these values when there is a moving load in case of bridges. So it is very much clear that in approximate method of calculation of bending moment, which is given by Indian standard IS 456, you can take the values from this table, and that means then you have to in the next slide we will be able to understand all these values more effectively. Now for shear force calculation you need shear force coefficients this table number 13 in IS 456. Just like this table number 12, we will refer table number 13 for the calculation of shear force value, that means shear coefficients we will take. Now here in this column you will find shear coefficients at end support. In these two columns you will find the shear coefficient support next to end support, outer side and inner side, and at all other interior support you can take these coefficients. Now how to take the bending moment and shear force coefficients from the code for the calculation of maximum bending moment and shear force values. So we have to take the bending moment and shear force is calculated by using the relevant formula by multiplying with coefficient. Suppose there is a formula for calculation of bending moment anywhere, suppose it is WL square by 12, then 1 by 12 will the coefficient and WL square by will be the formula. Similarly, in case of shear force calculation, if you get the formula, suppose WL by 4, then 1 by 4 will be the coefficient and WL will be the formula. So that means whatever be the coefficient you pick from these tables, you will multiply them with WL square for the calculation of bending moment and WL for calculation of shear force. Bending moment, as we discussed, they will be positive bending moment is calculated mid-span and negative bending moment near the supports. Shear force is calculated at supports because we know that shear force is maximum at the supports, that means supports are having critical shear force. Now let us try to understand how to calculate bending moment in case of a continuous beam or continuous slab. Now if you see in this figure number 1, you will find this is a beam, or if there is a continuous slab, even continuous slab you already have designed, you know that continuous slab is also designed as a continuous beam. So let us suppose this is a continuous beam. Now at the ends you are finding that these beam is supported at the ends on a brick wall. It is embedded into a brick wall. Its movement is restricted. It is not directly placed on the wall just like a simple support. It is a continuous beam, so it is embedded into the brick wall. Now this is your beam number 1, beam number 2 and so on. So here in this figure you will find this is a continuous beam having 1, 2, 3 and 4 spans, and you will find this is end support, this is another end support. This support number 1, this is a beam which is supporting the another beam. So this beam dotted one shown, it will be acting as a support to the beam. So this will be the first support which is next to the end support, and support number 2 will be known as intermediate support. Similarly, this support number 3 is also termed or designed as support next to the end support. Now in figure number 2, you can easily see here this is a brick wall and your beam is embedded in the brick wall. So that means it is not a simple support, it will just act like a fixed support because its movement is restricted. Now this span A is shown here. Similarly, this beam number 1 which is shown here, beam number 2, and then it is a continuous. So we have taken some section of the continuous beam for the understanding purpose. So this is span A, correspondingly this will be the span B. So it is very much clear that this A is the end span, B is the intermediate span. So end span as interior span or intermediate. We have taken this figure from R.C.C design book by Menon. So even for detail you can go through Menon. So it's a wonderful book for design of R.C.C structure to understand the basic concepts. Now look carefully. What you observe here, WU for ultimate load, that means dead load. So this is the middle of end span. This is the middle of end span. When you go through table number 12, you will find the coefficients 1 by 16 and 1 by 12. 1 by 16 for dead load and 1 by 12 for live load or imposed load. So by this formula, this type of formula, you will be able to calculate maximum positive bending moment at the middle of the end span. Similarly, you can take the coefficient value 1 by 12 and 1 by 10 from table number 12, which is for calculating the bending moment at the mid span of interior span. Now this is end span. I hope you are very much clear. This is end span and this is interior span. Now this is negative bending moment at near to the support. Now which is this support number 1? It is support next to end support. And table number 12 is giving us the coefficients for the moment for a support which is next to end support, not at end support, just next to the end support. So this support is next to end support. So you will be getting the negative bending moment at the support, which is given by this formula W dead load coefficient is 1 by 10. For live load coefficient is 1 by 9. You can go through the table number 12 to understand it effectively. Similarly, if you see here, it is also a support, but it is interior support. This support number 1 is next to end support, but this support number 2 is not next to end support. It is interior support. This support, you can see here, this support. So support number 2 is interior support, and when you have to calculate the bending moment, you have to pick the bending moment coefficient from table number 12. Then you will get coefficient 1 by 12 for dead load and 1 by 9 for live load. So we are taking both the negative. So it is very much clear that at the mid span you will be getting the bending moment, positive bending moment. Here you are getting positive bending moment, and at the near to the support you will be getting negative bending moment, and also in the interior support you will be getting bending moment which is negative. Now let us understand this. This is not given by code. Code is not giving any coefficient for the end support. So this is the actual formula WL square by 12 which you get from the structure analysis when you do the analysis. So here you are taking WL square by 12. Here is this 24 is not taken as coefficient. It is a standard formula. So this is at this support you will be getting negative bending moment. So from this figure it is very much clear that you will be getting positive bending moment at the mid of span and a negative bending moment at the support level. Now bending moment and shear force is calculated by using the relevant formula by multiplying the coefficient which we have already discussed. Positive bending moment is calculated mid span, etc. So this is just a revision of the step number 5. Now in step number 5 you are able to calculate what will be the maximum positive bending moment and what is the maximum negative bending moment. Similarly, you have to calculate shear force at supports, that is maximum shear force at support, from table number 13. So I have skipped this calculation part of shear force, so which is very much similar to bending moment. You have to pick the shear force shear coefficients from table number 13, just like we have picked it for movement coefficient from table number 12. So table number 13 you will be getting the shear coefficient, and by multiplying it with the WL you will be getting the shear force values For detail, when we do the design problem, we will be able to do it practically. Now, step number 6. Here code is restricting. Code is putting some limit. You have calculated bending moment, but here code is giving you limiting movement of a resistance. Basically, it is a check that you are applying a check based on grade of concrete, grade of steel, and based on the dimensions, that how much is the maximum movement of a resistance, that is limiting movement of resistance, which is allowed by IS 456, or you can say restricted by IS 456. Maximum bending moment obtained in step number 5 will be checked against MU limited as per code guideline we have already discussed by referring clause G1.1. That means you have to refer annexure G for IS 456, where MU limited can be calculated by using the formula mentioned below. This formula is given in the IS 456 in annexure G. MU limited is given by this formula. K is a constant, FCK is depends on grade of concrete, characteristic compressive strength of concrete, and B and D are the dimensions of the beam. So based on the dimensions of beam, if you have fixed B value and D, that means dimension, cross section dimension is fixed, grade of concrete is fixed, then you have to get the value of K. This value of K depends on grade of steel. So that means you are taking into consideration here grade of concrete, dimensions of beam, and grade of steel. And if you have fixed grade of concrete, grade of steel, and dimension, then how much maximum bending moment code is limiting or code is allowing, that we have to calculate. Now, grade of steel correspondingly, if it is Fe250, then K value is 0.149, and similarly for other grade of steel. Now suppose you have a section which is having dimension B and D, and grade of concrete is M20 and grade of steel is Fe415. So you have to put all the value and you will be able to get the MU limited, that means limiting movement of a resistance, and then you have to check it with the maximum bending moment coming through the calculation. Now for designing the section, because code is restricting that we have to design a structure member as under reinforced section. So if your MU maximum, which you have calculated in step number 5, you have calculated, and this is step number 6, that means MU limited restricted by Indian Standard Code should be more than maximum bending moment coming on the section. So if you follow this guideline, then your section will be designed as under reinforced. And if your MU maximum is greater than MU limited, then you have to redesign the section. Thank you.